Welcome to the I'm part of AICTE pre-run great training program for CSE students. I welcome you all for the session which is scheduled for the subject Database Management System, and the topic of the session is SQL. So this is the content of the session. So first we would like to I would like to give an overview about what is SQL. Then next, how we can define a database, and followed by we are going to discuss the basic query structure, and then we are going to discuss the additional or basic operations, followed by set operations, and how to make use of null values and aggregate functions, joins and subqueries. So this is a content of the session. So before proceed with, so SQL is an abbreviation of Structured Query Language, which is a standard for relational database management system. And we knew that RDBMS, okay, so which is shortly known for relational database management system. So RDBMS is generally a database management system which manages data in the form of tables, and each table consists of rows and columns, and we can bring the relationship among the tables. So by combining the relationship or by manipulating the relationship among various tables, so we can make a database in real world. So, in this particular slide, I would like to provide a glimpse on the history of SQL. So the term relational database was introduced by Dr. E.F. Code by the year 1970. And in the year 1974 to 1979, there is a project, okay, System R, which is a project handled by IBM Research Lab. They developed a language which is known as SQL. Okay, later it was renamed as Structured Query Language. So IBM Research Lab delivered the language SQL. And so by 1979, Oracle markets the first relational database with SQL. And by the year of 1981, the first available RDBMS system over DOS, that is the DOS operating system, that is which is a command prompt operating system. So we realized the first RDBMS system by the year of 1981. And apart from SQL, we have so many databases like Ingress, IDM, DG, SQL, Sybase. Okay, so these are the other database languages which was invented by the year 1981, 1982, 1984, and 1986 respectively. ANSI standards of SQL, okay, by the year 1989, 1992, 1999, 2003, 2006, 2008. So these are the major ANSI standard updates. So currently, so your SQL, so after 1992, the versions which are afterward 1992 are in use. So the major vendors make use of the standards, SQL standards, which are above 1992 versions. Okay. So what is the purpose of standardization? Why we need to go for standardization? So The standardization helps us to define the syntax and the semantics for your data definition. So, what are the ways we can define? What are the ways we can apply to define, as well as what are the ways we can use to manipulate the data which are stored in table form? As well as it also helps us to reveal the data structures and the basic operations which are performed over it. Okay, and it enables the portability of database definition and application modules. And it also specifies the minimal and the complete standards. Okay, the minimal support and the complete support. Okay, so also it allows later growth and enhancement to the standard by means of proposing referential integrity, transaction management, user-defined functions, and so on. Okay. So in simple, we can say the standardization helps us to specify the syntax and semantics of how we can opt for data definition and manipulation, followed by what are the structures and the basic operations we can proceed with. Okay. So here comes the SQL environment. In SQL environment, okay, I have collected the important terms which are to be used with the SQL environment. So catalog is a combination of schemas which constitutes the description of a database, whereas schema is a structure which contains the description of objects created by a user. So it can be a table, or it can be a view, or it can be a constraint. Okay, so schema is a structure which describes the object. Okay, so whereas the collection of schemas are known as catalog. So in SQL, that is the commands in SQL are broadly classified into three categories. First one is data definition language, which helps us to define a database. That is to create a table, alter, as well as drop a table with establishing a constraints. So the second category is data manipulation. So as its name implies, so it includes the commands which helps us to manipulate or query a database. And the next category is data control language. So in data control language, we have commands that controls a database. Okay, so by using data control language, you can enforce the security also. So here comes a pictorial representation or schematic representation of a typical SQL environment. So here, so this is the SQL environment. So the SQL environment consists of catalog and so catalog is nothing but a combination of various schemas which constitutes a database. So here product is a database and here development is a database. So to bring this database, we have information schemas. So the schemas facilitates the respective database. So the collection of catalog forms a database, that is database management system. So database management system is a software, okay, so which infers information from the database what you have created. Here your dev and product are the databases. So database management system is a software like SQL. Database management system is nothing but SQL here. So by using SQL in the form of programs, we can query we can make a query to retrieve information from the database. And the informations are used by the users to make a decision. So the user initiates queries through programs, okay, and the program is executed by the software Dbms, okay, and the software extracts the information from the database, okay, so which is here addressed as a catalog. So here, this is a short uh, glimpse on what is DDL, what is DML, and what is DCL. So DDL is data definition language. It allows us to define the database. That is, you can create a table, view, index, okay, and you can alter the table content. That is, you can alter the structure of the table, as well as you can drop or truncate the table whenever there is no need for it. Okay. So DDL enables a physical design. Okay. So whereas DML, okay, so the manipulation operations like insert, update, delete, and the query in the form of select, okay, allows us to manipulate information. Okay, so we can um, infer the information from the database by means of DML. So DML allows us to implement, so it enables implementation support. So next comes DCL. So DCL facilitates a control over a database. So you can maintain the data in a database by establishing a control over the database. So you can use the commands like grant and revoke. Okay, so by means of grant and revoke, you can apply permissions or you can enforce the permissions. Okay, who and all can view the database or who and all can manipulate the database. So like that, permissions you can avoid by using DCL. So in that way, you can facilitate a control over, you can maintain a control over the database. So DDL enables the physical design, whereas DML facilitates the implementation, whereas DCL supports maintenance. Okay, so let me discuss about data definition language first. So as we discussed earlier, so data definition language allows us to specify or to define the data. Okay, so which includes it, it can be a schema, that is we can define the schema for each relation. Okay, so whereas the schema consists of domains. Okay, so domains are nothing but the values which can be uh, specified, okay, for the attribute of the relation. Okay, and integrity constraints, that is the constraints to be allowed, that is what kind of values each attribute can hold, or what is the key attribute. Okay, so like that constraints also we can define. So by using data definition language, you can define the schema for a relation. So this relation consists of a number of attributes. So the number of attributes allows a set of values which are known as domain values. So these are the domain types in SQL. So to support character, we can use char or varchar. So to support numbers, we can use integer, small int, numeric, okay. And for float, we can use real or double precision or float. So these are commonly used domain types in SQL. So to create a table in a database, we have to follow the steps. Okay, so what is the first step? So first we have to identify uh, the number of attributes which constitutes a table. Okay, and we have to ascertain the data types of the attributes. Okay, so what are the data types? Okay, for example, for a student relation, to create a student relation, so what are the attributes? So we have to enlist the attributes of student relation. For example, roll number, name, and age are attributes of student relation in the sense. So the roll number, okay, takes what kind of data? So the roll number can be a mere integer, or it can be uh, character, that is variable length character. Okay, suppose I want to use the roll number as 2021 PITCS some 2042. So in that case, I cannot use integer as its data type. So I can use varchar. So like that. So you have to enlist the necessary attributes which constitutes a relation, as well as you have to pick the appropriate data types of each and every attribute. Okay. And by the next step, you have to identify the columns which cannot be null. Okay, so which columns can take null values and which cannot take null values. So you have to identify the columns. Okay, and you have to identify the columns that must be unique. Okay, so based on that only we can make a choice of primary key. So which particular column is that is uh, which column is helps us to identify each and every tuple, okay, of your relation, unique in the sense. Okay, so that particular attribute or a column can be used as a primary key. Okay, and there exists a relationship between two tables. So in the sense, is there exist any foreign key relationship? Okay, so that we have to investigate, and we have to select, okay, the primary key and foreign key mix. Okay, then determine the default values. So we have to check whether any of the particular column or attribute, okay, should maintain a default value or not. If so, what is the default value? And next we have to identify the constraints on the columns. So it can be a domain constraint or key constraint. Key constraint in the sense referential integrity constraint. So which we will discuss in our next session. Okay. So here key is an attribute which helps us to retrieve a tuple, okay, from a relation in a unique manner. Okay, that is considered as key. So that information is enough for us now. Okay, and by next we have to select whether we are going to append index for the table or not. So these are the things we have to uh, do before creating a before making a decision to create a table. Okay, and to create a table in SQL, so we have to follow the syntax. So this is the so we have to use the create table command, and this is the syntax. Okay, so create table followed by this is R means relation name. So we have to provide the name to the relation, and within parenthesis we have to enlist the attributes. Attribute 1 followed by its data type. Okay, and next, if there exists some integrity constraint, okay, so we can make it a definition. We can make a definition after providing the attribute list. Okay, so this is the syntax for create table. So here comes an example. So here a table named as instructor is created, which has the attributes like ID, name, department, name, and salary. So ID is a character type, and name is variable length character, and department is varchar, and here the salary is numeric. So here comes enterprise data model. So here we have relations like customer, that is we have a relation like customer, product, order, and order line. Okay, and the customer has two attributes, customer ID and name. Okay, among these two, customer ID is the attribute or the column which helps us to retrieve customer, that is each customer from your customer relation. So customer ID acts as a primary key here. That is, customer ID is the key attribute because that is, customer ID will be unique in nature, whereas customer name, the same name can be uh, repeated. Okay, so for example, in real world, then the same person, that is, the different person can be provided with a same name. Okay, so whereas customer ID will be unique. Okay, so attribute which helps us to retrieve a tuple from your relation in a unique manner. Okay, must be elected as a key attribute. So customer ID acts as a key here. Likewise, product ID acts as a key here. Okay, so for this schema, for this enterprise data model, so we have to use, that is, we can create a table. So this is the snapshot. So customer ID must be not null, and customer name. So what are the steps we have discussed in creating a table? First, we have to enlist the attributes, and we have to assign, or we have to annotate the respective data types for the attributes, and we have to select which columns or attributes allow null values and which do not allow null values. So here customer ID and customer name should not be null. Okay, so customer ID and customer name are assigned with not null. And here this is a constraint. So here customer ID is elected as a primary key, because customer ID is unique in nature. So we can use the customer ID to select each and every tuple. Okay, so because customer ID has different value. So likewise, order, product, and order line. So the schema for customer, order, product, and order line is done. So identify the attributes and annotate the respective data types. And here, so this is a check constraint. Okay, so this is another form of constraint, check constraint. Okay, so in previous case we have discussed a key constraint. So how to facilitate, or how to establish a key constraint. Okay, and this is a referential constraint, that is the we have a customer and order, whereas the order ID, okay, has a relationship with, that is we have this customer and order has implicit relationship. So here order ID refers the customer ID from customer table. So each customer must have a order ID. So here order ID refers the customer ID of customer as its prime. Okay, prime key. So here uh, this is whereas your order is a child table, whereas customer is a parent table. So here customer ID in order table is considered as a foreign key. Okay. Okay. So, and one more thing is primary key can be a composite. Means that we can have more than one attribute. Okay, as a primary key. So in order line, order ID and product ID combinedly used to retrieve the tuples from the order line. So the primary key can be composite. And likewise, we can set a default value, okay, to some attributes. Okay, so for example, order date. Okay, so for the attribute order date, I can set the default value as sysdate. Okay, so in according to that is we are making order through the system, isn't it? So the system has a system date. It maintains a date. So uh, uh, so in what date the order is placed. So that particular date can be extracted from the sys date. Okay. So we can use the date value as that is the value for date as default value for date as sys date. Okay. So likewise we can set uh, default value, and here this is an example of domain constraint. So here we can check that whether the product finish is in the category of whether cherry, natural arch must be in the category of. Okay, so these are the possible that is category of product finish. Okay, so we can that is establish a check constraint. Okay, so the product finish must be within this domain only. So like that things we can define while creating a table. And this is an example of foreign key. For example, we have customer table and we have order table. So customer table has attributes like customer ID, customer name, customer address, customer city, state, and postal code. Okay, and here the customer ID acts as the primary key. Okay, whereas in order table, so we have attributes like order ID, order date, customer ID. Okay, so here we have customer ID, so which is uh, taken from the table customer, because there exists a relationship between customer and order. Okay, so the customer ID attribute, okay, has used in order table. So as we have some 1 is to n. Okay, so the customer can have a single or more than a number of orders. Okay, so each customer uh, can have some one or more orders. So there exists MSTN relationship between customer and order. So that's why we have used customer ID here. So for order table, the primary key is a composite, isn't it? So because so to retrieve the tuples of order, we have to use order ID and the customer ID, okay, as the primary key. So whereas customer ID is the primary key of the relation customer. So here customer ID is accounted as a foreign key. Okay, so which has its place in original place in customer. Okay, so here we are referencing in order, we are referencing the customer ID attribute from the customer relation. So that's why, so here customer ID is called as foreign key. So the foreign key relationship is known as referential integrity constraint. So it ensures the foreign key values of a table must match the primary key values of a related table which has 1:m relationship exists between. Okay, so this referential integrity restricts the deletion of primary records, updates of primary records, and some insertion of new records. So that's all about create. So under DDL, we have create, alter, drop. Okay, so we have discussed create. So using create table, so you can create a relation. Okay, so to create a relation, first you have to identify the attributes and you have to associate the appropriate data types, and you have to make a selection of for which columns or attributes we can allow null values and which columns we should not. Okay, and you have to pick a key attribute. Okay, so which attribute can access a primary key, whether it is a single attribute or a composite. Okay, so the key attributes can be defined in the form of constraints. Okay, so apart from a key constraint, okay, you can use a referential integrity constraint. Okay, so to ensure the foreign key relationship between two tables. Okay, and you can allow some domain constraints also. Domain constraints in the sense you can restrict the values for the attribute. Okay, so you can restrict the values of the attribute. So the values can be some group of values. Okay. So these are the things we have discussed in create. And next is changing. You can change the structure of the table. Okay. So for changing the structure of the table, what you can that is you have to use the command alter table. So the syntax is alter table, table name. Okay, and followed by alter command. What you can do now, you can add new column, or you can um, change the data type of the column. Okay, and you can drop the default value, or you can drop the particular column from the relation, or you can add the constraints. Okay, like key constraint, check constraint, you can add it. Okay, later on. Then to remove the table from this from your schema, you can use drop table, table name. This is the syntax. The syntax is drop table, table name. Okay, so drop table, table name. So drop table statement allows you to remove the tables from your schema. Okay, and another one command, that is truncate table. So truncate table statement allows you to remove the table, that is it retains the structure of the schema. Okay, so that is the difference between drop and truncate. So in order to remove table, you can use drop or truncate. A drop completely removes the table from your schema, whereas truncate retains the structure of your schema. So that's all about your DDL. Okay, so we are moving on to DML. Okay, so in DML, first we will look into how insert works. Suppose I want to add. So far I have created a table. Okay, so I have created a structure of the table. So I want to populate data to that table. So how can I do that? Okay, so you can add one or more rows to a table by using the command insert. Okay, so here comes the syntax. So you have to use insert into. Okay, this is insert into table name followed by values, and within parentheses you have to specify the values of the attribute. Okay, defined attributes as you defined in your definition. Okay, so you have to follow the same order of specifying your attributes values. So here, this is the okay syntax. So insert into table uh, values, okay, and you can supply the values of the attributes within parentheses. And you can pass to some particular group. Suppose some attributes are some attributes have some null values. Okay, so you want to pass values to some particular attributes, means you can follow this index. Insert into table name. Okay, so within parentheses you can specify the parameter list, that is attribute list. Okay, so first is the product ID, second comes description, product finish, and the standard price. Okay, so for these attributes we can facilitate the values. So one is for product ID, end is the description of product, end table is the description of product, and the product finish is belongs to the category cherry, and this is the standard price. Okay, and we can also insert the values from another table. Okay, so here comes the index. So insert into, okay, T. So here we can use the query. So the relevant values, okay, should be extracted by using a query. Okay, and those values we can pass it to, or we can insert into the table. So to remove a particular row from a table, so we have to use delete command. So delete from customer. So here we can use, suppose I want to delete a particular row, means so I have to specify the row using var class, the particular. Whereas to delete all rows, we can use the command delete from customer T. Okay, delete star star. Suppose we are using star, means it indicates that all fields are all attributes of the customer has to be removed. Okay, so insert, delete we have done, and next is, suppose I want to update the value, okay, of a particular uh, attribute. So in that case, I can use update command. Update table name set, this is your attribute. Okay, so set attribute equal to, this is the new value. Okay, and here comes, so I want to update a particular row. Okay, so a row which has a product ID equal to 7 has to be changed its product standard price is 775. Okay, not all the rows. So I can select a particular row by using var class. Okay. So here, insert, delete, update are the forms of DML commands. Okay. So whereas to retrieve any particular information from your table, so we have to use, you have make a query. Okay. So the query can be uh, established over your database by using select command. So this is a basic query structure. So select attribute list, okay, attribute list from relation list, where this is your predicate or a condition. Okay, so this is the common structure of a query. Okay, select attribute list from where, from which relation. Okay, and it has to meet what is the condition. Okay, that should be specified in predicate. So select from where. Okay, your basic query structure uses three main keywords: select. So out of various attributes, we like to extract, or we like to retrieve which set of attributes. What is our interest of attributes? Okay, so that has to be specified with select, and the attributes are part of which relation. Okay, so that has to be specified with from, and where ascertains the necessary condition to be met with. So this is and the result of the particular query is a relation. Okay, it's also considered as a relation. It is also saved as a relation. So the select class lists the attributes desired in the result of a query. Okay, so which is equivalent to the projection operation what we have discussed in relational algebra. Okay, so for example, find the names of all instructors. Okay, so to retrieve the names of all instructors. Okay, so what is the attribute we are interested? So we would like to want the names of the instructor. So the attribute of interest is name. So select name, and from which relation? It is from the relation instructor. So select name from instructor. Okay. It displays the names of all instructors. Okay, so if here SQL names are case sensitive. Okay, so we have to make a note of it. So suppose you have defined the name as n caps and remaining letters is small means. So you have to use the same naming conversion. Okay, so suppose you are using a different name means it throws an error. Okay. So to disallow duplicates in relation, we can use the keyword distinct. Okay. So there will be multiple entries for the same department. Okay. So for example, for in CSE, there will be a number of instructors. Okay. So whereas I would like to know uh, uh, the departments. Okay. The departments are from distinct departments from the relation instructor. Okay, so in that case I have to use the distinct keyword, so which disallows duplicates. Okay, so whereas suppose you are allowing all keyword means uh, uh, so how many entries pertains to CSC would be repeated. Okay, so in select class, we can allow arithmetic expressions. Okay. So suppose, so here is an example. So select ID, name, salary divided by what? 12. Okay. So like that, uh, suppose we are, okay, likewise we are having a date of birth. Okay. So, so we can compute age. Okay. By means of date of birth using some arithmetic operations. So in select class, we can allow arithmetic operations. Okay. So in select class, what we can do in select class, we can enlist the attributes of interest. Okay. And so to disallow or to filter the duplicates, we have to use distinct keyword. Whereas to allow all entries, so we have to use all keyword. And so in select, we can apply the arithmetic operations. Okay, so that is all about your select. The for the from class works on your relations. Okay, so the attribute of interest has to be uh, that belongs to which relation. Okay, so that is taken care of your from class. So now we are going to discuss about var class. So the var class specifies the conditions that the result must satisfy. Okay, so suppose instead of displaying the names of all instructors, okay, I would like to display uh, the instructors who are belongs to computer science. Okay, so in that case I have to exercise a condition. Okay, so I want to filter out the name of the instructors who belongs to computer science. So the predicate is defined by using var class. So you can set or specify the conditions the result must satisfy through var class. So here is the syntax. Select attribute from relation where condition. So the department name must be computer science. Okay. So as well, you can use a composite. Okay. A composite condition. Okay. By using the Boolean operation, logical connectors like and, or, and not. Suppose I want to uh, list out the instructors of computer science and who receives salary greater than 80,000. So then I can, in that case, I can use the and, okay, the logical connector and to extract such information. So this is we already discussed. The front class lists the relations involved in the query. Okay. So star means all. Okay. Select star means all attributes. So select all attributes belongs to instructor and teachers. It's all about from class. So in var class, okay, so we can include a string matching operator. Okay, so the operator like uses patterns that are described using two special characters. One is percentage and underscore. Percentage means matches a substring. Okay, whereas underscore means matches a particular character. So for example, I would like to enlist the name of instructors whose name uh, okay, whose name has a substring DAR in between. Okay, so DAR in between. So um, before DAR, there can be any number of characters, and after DAR, there can be any number of characters. Okay, so for a substring, okay, for any substring, we can use percentage. Okay, underscore means for a particular character. So, for example, I would like to enlist the name of instructors whose name starts with A. Okay, so in that case, I can make a condition that the name like underscore percentage. After underscore, there can be any substring. So like pattern matching we can do, and we can order. Okay, that is we can order the tuples by ascending or descending order. So based on the selected attribute. Okay, so based on the selected attribute we can make a order. Okay, so select distinct name from instructor, order by. So the default ordering is ascending. Okay, you want a descending order means, so after order by, that is the name of the attribute, you have to use explicitly, you have to specify DESC, descending. Okay, because the default it is ascending, it displays uh, the tuples in ascending order. Okay, and it is in var class we can so in var class to ascertain the predicates we can use between comparison operator. Suppose for example, find the names of all instructors with salary between 90,000 and 1 lakh. Okay, so for this, instead of using greater than or equal to and less than or equal to, we can use the between keyword. Okay, so between 90,000 and 1 lakh, so we can use between. So duplicates can be disallowed using the keyword distinct. And here comes the set operations. So union, intersection, except are the set operations. So here, so we have So except first query, we want the result of second query. So in that case, I can use select second query except, and we can this is aliasing. Set listing T means so alias name for instructor. S is alias name for instructor. So we can use aliasing concept. Union, intersection, and except are the set operations. So we can combine the tuples, okay, by using union, okay, and we can extract the distinct tuples, the common tuples, okay, the common tuples into relations using intersect, and we can extract the tuples which are in relation 1 and which are not in relation 2, okay, by using except. Okay, so these are the set operations we can perform over. And so for some attributes, we can allow null values. But the key attribute should not have a null values. Okay, and we can perform the aggregate functions like min, max, average, count, okay, over your select class, and we can group it, okay, we can group the resultant based on the aggregate function. So here, find the average salary of instructors in each department. So to extract the average salary of instructor corresponds to each department. So we have to group the salary of instructors correspond to each department. So first we are extracting the average of salary, okay, and we are making a group through the department name because I want the salary of instructors based on the department. So group by has department name as its. So we can exercise aggregate functions and we can group the resultant. So based on some attribute as well, we can certain some uh, conditions to be satisfied, okay, using having class. Here we cannot use where, okay, here the having class, we can use the having class to make your predicates, to define your predicates. So for example, so I would like to enlist the name and average salaries of all departments whose average salary is greater than 4,000, that is 42,000. 4,000, it is 42,000. So, what are attributes of interest? Names and average salary. So the attributes are select, department name, average salary, and the relation is from instructor. Okay, and the average salary must be grouped with its department name, and I would like to the average salary which is greater than 42,000. So the predicate, okay, so average salary greater than 42,000. Okay, the predicate is specified with the help of having class. So suppose you are using aggregate function in your query, means you have to use the predicate with the help of having class only instead of where class. Okay. So this is the important classes of select statement. So first one is select, which lists the columns. Next class is from, which indicates the relations are tables or views. And next class is where, which indicates the condition. Okay. And next class is group by, that indicates the categorization of result. And next we have having. So for aggregate functions, uh, to specify condition, we have to use having. So to indicate conditions under which category will be included. Okay, so for that we have to use having. And next is ordered by. So ordered by is used to uh, order the tuples in either in ascending or descending order. By default, it is ascending order. To make it as descending order, you have to explicitly specify it. Okay. So these are the various classes that are to be used with your select statement. So this is a schematic structure. Okay. So this is a statement processing order. So first, from the particular relation and applying the necessary condition, okay, grouping the condition with group by, facilitating having condition. Next, we have to select uh, the interest of attributes, that is, and we have to make it as ordered. Okay, so this is the order. So the SQL select statement works in this order. So first, it retrieves the relation, and in relation, suppose we exercised a particular condition, means the condition, that is the tuples which meets the condition is alone extracted, and from the tuples, uh, the columns which are interested, so that we have to uh, identify. So only those columns has to be displayed. So these are some examples. So to retrieve products with standard price less than 275, so we have to write a query that select. Okay, so we would like to extract the products. Okay, so the product description, standard price. Okay, so from the table product. Okay, where the that is the condition is the product standard price must be less than 275. So this is the query we have to use to extract the product information. Okay, that is the products, enlist the products which whose standard price are less than 275. Okay, so this is alias name. So you can give a alias name to your relation. Okay, and next example is using aggregate function. So in previously we have used, that is we have checked aggregate function average, and this is another aggregate function count. Suppose I want to retrieve the number of tuples, okay, in your order line, okay, and whose order ID is 1004. So in that case I can use count of star, so which retrieves the number of tuples matches the particular condition order ID equal to 1004 for the relation order line. And next is with Boolean operators, that is like and or. So you can make a composite condition using the logical connector or and you can use the string that is pattern matching, percentage and underscore string operations. This is a schematic diagram. And you can sort the result by using order by class. And this is an example of that is aggregate function with group by class. Suppose I want to categorize, okay, I want to categorize the resultant attributes of particular relation, okay, so based on aggregate function. So in that case I have to use group by. and having class. So when we have to use having class or not. Okay. So next comes joins. So joins allows us to join the tuples of different relations. So in SQL there exist nearly 5 types of join: inner join, full outer join, left outer join, right outer join, and cross join or partition products. So these are the 5 types of join. Inner join in the sense we can combine the tuples of the same relation. Okay, so that is inner join. Okay, so by using alias name, okay, you can do it. Whereas, yeah, this is inner join, schematic representation of inner join. So next comes left outer join. So left outer join contains all records between T1 and T2 that meet the join condition, and then any records in T1 that don't meet the join condition. Okay, so here, so inner join accounts only the tuples which meets the join conditions. Okay, join condition are deployed between the relations T1 and T2. Okay, so whereas the left outer join, along with the tuples of inner join, it includes, okay, the records which are in your left hand side table, that is a T1, and which do not have in T2. Whereas the value for T2 are padded with nulls. So this is the schematic of left outer join. So in case of right outer join, in addition to the common tuples of T1 and T2, it accounts T2, okay, it accounts the tuples of T2, and it pads the relevant value for T1 as null. So this is the schematic diagram for right outer join. Full outer join in the sense, in addition to T1 and T2, that is the records between T1 and T2 that meets the join condition, the combination of left as well as your right outer join are also appended onto your resultant relation. So this is the schematic representation of full outer join. Cross join, the another name for cross join is Cartesian product. Okay, so which simply connects or combines the tuples of two relations. So if there exist m tuples in one relation and n tuples in another relation, means your Cartesian product yields m is to n tuples in your resultant relation. Then subqueries. Subqueries in the sense you can use the select class or select statement inside another select. Okay, so the select can be used either from class or where class. Okay, to frame a subquery, you can embed a select either within from or where. So this is an example. So here this is an subquery. For example, select star from stackers. Okay. Yes, comma, select star from address book. Okay. This is a, that is a select statement is embedded into another select statement. So here is one select statement which is embedded into another select statement. Here the select statement is embedded within from. So likewise, we can embed a select statement in where. So in this session, we have detailedly discussed the SQL, that is what is SQL, and the common, that is the environment of SQL. So what is catch-up, what is schema, and what are the commands, what are the categories of commands are available in SQL, and each and every command set of the three categories of SQL are also explained detailedly. Thank you, students. We will meet you in next session. The next session would be on integrity constraints. Thank you.